Okay, so what if you could give radar a superpower? I mean, what if we could make it see with the speed and the clarity of light itself? Well, today we're going to dive into microwave photonics radar, a technology that's doing exactly that. And trust me, it's changing our world in ways you might not even expect. But to really get why this is such a huge leap forward, we first have to ask a pretty basic question. What's holding our current radar systems back? Because every technology, I don't care how advanced it is, eventually hits a ceiling. And for radar, that ceiling is made of pure electronics. So before we get into the really cool breakthrough stuff, we've got to understand the problem. We're talking about a fundamental electronic speed limit that has basically defined what radar can and can't do for decades. Look, conventional radar systems are incredible feats of engineering, no doubt, but they're running into some serious walls. Their bandwidth is pretty limited, which means they struggle to get a really sharp, high-resolution picture. They're also super vulnerable to electronic jamming and interference. And as you try to push to higher frequencies to see more detail, the signal just gets weaker and weaker, and the hardware itself, it gets big, clunky, and heavy. And this right here, this slide gets to the absolute heart of it. This isn't just a design flaw you can fix, it's a physical limitation. The electronic components themselves, all the little oscillators and mixers and filters, they just can't physically keep up when you ask for more speed and more data. They are literally hitting a wall. So how do you get past an electronic speed limit? Well, you change the highway you're driving on. And this is where photonics, the science of light, comes roaring in with an incredibly elegant solution. And that brings us to the main event, microwave photonics radar, or MPR for short. So instead of trying to do everything with electronics, an MPR system uses light to create and manage the radar signals. It's a hybrid, really. It combines the raw power of microwaves with the unbelievable speed and purity of light. So if you want to boil it all down to one simple idea, it's this. It's not about replacing electronics with light. It's about a partnership. Optics and microwaves are working together as a team to pull off something neither one could do on its own. And that partnership is the key to unlocking a whole new level of performance. Now, that all sounds great in theory, right? But how does it actually work? I mean, how do you get a radar signal to, ride on a beam of light? Well, the process is actually surprisingly straightforward when you break it down. Okay, let's just walk through this. First, a super stable laser creates this perfectly pure beam of light. Next, you take your microwave radar signal and you basically imprint it or encode it onto that light beam. Now, all the really complex processing, the filtering, the shaping of the beam, all of that happens while the signal is in this light-based form, where it's way faster and cleaner. After that, it gets converted back into a microwave signal to be sent out. And finally, when the echo comes back, it's converted back into light to be analyzed. It's kind of like giving your radar signal a ride on a flawless, interference-free fiber optic supercar. So, by doing all this heavy lifting in the optical world, microwave photonics radar gets some incredible new abilities. And these are the superpowers that directly solve all those problems we were just talking about. Remember those limitations? Let's tick them off. Limited bandwidth? Nope, MPR has ultra-wide bandwidth. Vulnerable to jamming? Light is basically immune to it. Signal loss at high frequencies? Optical fiber has incredibly low loss. Bulky hardware? Photonics can be put onto tiny little chips. It's a complete game changer. Every single weakness of conventional radar becomes a strength for MPR. Okay, I keep using that term ultra-wide bandwidth, but it can feel a little abstract. What does having that superior capability actually let you do? What does it let you see in the real world? It means this. Systems have been demonstrated with a range resolution of just 2.7 centimeters. That's just astonishingly precise. It means the radar can tell the difference between two objects that are barely an inch apart. It's the difference between seeing a car and seeing the rearview mirror on that car. So with that kind of incredible power, where is this technology actually making an impact? Let's take a look at how this high-tech future of radar is already starting to play out. Yeah, no big surprise, the biggest driver right now is advanced military applications, where that kind of precision and resistance to jamming is absolutely critical. But what's really exciting is the potential for the future of cars. I mean, think about self-driving cars that can see the world in higher definition than ever before. It's also completely changing the game for high-res imaging, for things like seeing through walls, or mapping terrain with insane detail. And if you want a jaw-dropping, real-world example of what this can do in the defense sector, Check this out. A microwave photonics radar system has reportedly been able to track 10 hypersonic missiles. We're talking missiles traveling at 20 times the speed of sound, with almost perfect accuracy. That's a feat that would be completely unthinkable for most conventional systems. And at the end of the day, this table just lays it all out, plain and simple. On one side, you've got the purely electronic systems with all of their built-in limits. And on the other, you have this electro-optic hybrid that just smashes through those limits across the board, from bandwidth and interference immunity all the way down to the physical size of the hardware. It's a fundamental shift in how radar works. Now, a really quick but important point of clarification here. When we talk about using photonics, it's easy for your mind to jump to, quantum technology. But microwave photonics radar is different. This stuff uses classical light and lasers, not the crazy quantum entanglement you might hear about in theoretical quantum radar. This is technology that works on principles we already understand, just applied in a totally revolutionary way. So we're left with this really powerful idea. By putting radar signals onto light, we've essentially given ourselves a new set of eyes, ones that are sharper, faster, and way more resilient than ever before. So the real question isn't just about tracking missiles or guiding cars, it's about what entirely new things about our world we'll finally be able to see. What new discoveries are waiting for us just beyond those old electronic limits?